Fair? Good-ish? We're getting there. We're getting there. Hey, I'll tell you what. Before we jump into a new data set, why don't we finagle this one a little bit? Let's finagle. Can you create data for me? Out of 1,000 people, can you create data for me that shows the vaccine does not appear to be working? Can you use the exact same setup? Go back to stat tests, one prop z test. Can you create data that shows me that the vaccine does not appear to be working? Can you create data? And I expect everybody to have slightly different results, I would imagine. Can you create data that shows the vaccine is not working? So we're still assuming that the flu rate is 12% in the general population. We're still surveying 1,000 people by giving them 1,000 vaccines.
Would we change the...
Change your X.
It's anything over 120.
No.
Boom! Jared's already got the cutoff value. Very nice, very nice. So give me a value of X that shows the vaccine does not appear to be working. Give me a value of X that shows the vaccine does not appear to be working.
115.
We have a vote for 115? A vote for 120?
Or greater.
Or greater? Okay. Mary, what are you thinking? 110? Love it. Let's test each one of these things. Let's go with 120 first. Are you guys still messing? Maybe I should stop. Maybe we should. You guys are still messing. 110, 115, 120. Jamie?
Are we leaving the symbol the same?
Yes. We're still testing to see whether or not the vaccine is working. So we're going to leave the symbol at less than for sure. For sure, leave the symbol at less than. But now we want to get data back that shows no, don't think the vaccine is working. So can we throw 120 in there real quick for starters? What happens when you do 120? Now you might have been able to predict what's going to happen right here. You shaded exactly half the curve. Because 120 is right at average. It's right at average, which means you're perfectly within the confidence interval for what you were expecting. You were expecting 12% to get sick, and exactly 12% got sick. Is that the smallest number that can get sick, but still make you think the vaccine's not working? I had to go for 115. Let's try that one. One prop z test, 115. Oops. What do you think? If 115 out of 1,000 got sick, is the vaccine working or not with 115? Look how big that p-value is. 31%. That's too big. That means you're still within that confidence interval. You're still within. The confidence interval is somewhere about, let's see, it's about there. It's about here. That's kind of the cutoff. Ish. So we're still well within it with 115. Go ahead, Jared.
Yeah, I'm confused because earlier you said that the 12% is just a parameter. So there's no...
Correct. Now we're talking about the sample. Now we have to have a margin of error. Right, 12% of the general population out of the 1,000 in our sample. I love this. Thank you for bringing that up, Jared. There's a definite difference between the 12% parameter measure that's in the population and out of the 1,000 in our sample, which has to have a margin of error. Thank you.
Okay.
How about 110? Can I go for 110? Yeah? Okay, notice we got less area. But it's still too much to believe the vaccine's working. What's the smallest number of people that you can put in there and still get a p-value that's too big to believe that your vaccine's not working? Ashley?
100.
We've got 104. 104 sounds like it does the trick. 104 sounds like it does the trick. Here she comes. Oops, I drew that in the wrong place. Look, just about 6%. So that's still, 104 is still just enough to keep us in the confidence interval.
103, 4.9.
4.9 comes out. 4.9 is technically below 5.
Yeah.
Which brings back, somebody asked a phenomenal question last time. I forget who it was. What happens when something like this happens? Who asked me that awesome question last time? What happens when your p-value comes in really close to 5%? Who asked me that? That was such a good question. Oh, damn. It was such a good one. I'm going to give you all credit for it. What happens? What happens if you get that, Ashley?
Practical interpretation of your data?
Forget that. I want to go statistically significant. I don't like, not forget that. I don't want to worry about practical interpretations. That requires us all to be experts in everything. I want to see if that's statistically significant. It doesn't look like it right now, but it's damn close. So what can I do? Say that louder. Alina, collect more data. Check this out, friends. Watch this z-score right here. Negative 1.557. Keep that in the back of your mind, okay? 1.557. Let's go back and collect some more data. Okay? And let's suppose we got 104 out of 1,000, right? We got 104 out of 1,000. Suppose we asked 1,000 more people and got the exact same results, which means now we'd have 208 out of 2,000, wouldn't we? Wouldn't that result in the exact same percentage? 10.4%, right? It's 10.4% again.
But we 202 at that point, wouldn't it?
If it was 104, if we doubled everything, it'd be 208 out of 2,000.
Well, I thought it was 101.
100, no, we did 104 is kind of like this base
gotcha.
cutoff.
No.
101 was from our data, yes sir, yes sir. Okay, see what I did right here, friends? I made the assumption. Ashley told me 104 out of 1,000 gets me right to that cusp of 5%. And we get there, we're like, crap, I think the vaccine might be working. But 1,000 wasn't a large enough sample size to see it. Wasn't a large enough sample size to see it. So what I'm going to do now is I'm going to replicate the study. I'm going to get 1,000 more people in there, and look what happened. I got 104 out of that 1,000 to also get the virus. So now, out of all 2,000, 208 total have gotten sick. 208 out of 2,000 is the same p-hat as 104 out of 1,000. It's the same, but what? Say that.
You're doing the 95%.
But yes, watch friends, whoops. Look at that.
Yeah.
It's the same percentage, 10.4%. But look what happened. How the hell can that be? How can it be, if all you did was double your sample size, how can it be that all of a sudden it's significant when you have 208 out of 2,000, when before you had 104 out of 1,000, it wasn't significant? Lindsay?
Is it because the margin of error got smaller?
Yes. When you have larger samples, what happens to your curves?
They go up.
So this curve looks like this. The other curve looked more like this. That's what the other curve looked like. Another one, where it was before, had more area attached to whatever. You see the point? You see what's going on here, friends? You see what's going on here? Same oh, I do now. I see you right on the picture, YouTube right on the wall, no big deal. So the idea is that an increased sample size, this is the easy, quick and easy answer. If you get to the cusp of statistical significance and you think something's actually going on, go get some more data. If your data was representative of what actually is going on, you're probably going to get close to it again. And all that's going to do is shrink your standard error down. I did make a little bit of an erroneous assumption with that one, didn't I? I assumed that with 1,000 more, you got exactly 104 to get sick again. That was a little bit fictitious, correct? But assuming that you didn't get an outlier data set in the first place, you're probably going to get close to that, which is probably going to be pretty close to this result here. Does that make sense?
Yeah.
This re-answers whoever, I'm going to give you all credit for it, that great question last time about what happens when you're close to 5. What happens when you're close to 5%? You can do that. That's one way of dealing with it.
So if you're not talking to your neighbor, you're talking to Rebecca Walker-Sands, is that inconclusive and you need more data?
If you have a big p-value, yes ma'am. It's inconclusive for some reason. It could be inconclusive because you made a type 2 error. Back, friends, let's back up. Let's back up again. I want to re-answer Zoe's question. Hopefully we're answering this question for you well, Zoe. Everybody back up to your tests. Go back to 104. You know what? Let's make it even more obvious. Make it 124 out of 1,000. Let's make sure we get a big p-value, okay? Let's make sure we get a big p-value. 124 out of 1,000. Let's draw that one. Huge p-value, huge p-value, huge p-value. We believe at this point that the vaccine is not working. There's no reason to think it's working. Okay, big p-value. Ashley, go ahead. What's on your mind?
If you're looking at this, that's like the opposite of what we wanted. Is it proving another hypothesis?
Hold that thought. Give me 2 more minutes. Thank you for reading my mind. I'm actually glad you said that. So right now, what we do is we can't believe this, so we're believing this. Right? We're up in this. So we say that. We say it does not appear the vaccine is working. So what kind of result is that? Positive or? That's a negative test result, isn't it? That's a negative test result. That's a negative test. We're saying the vaccine doesn't appear. We're believing H0. We're believing H0. Okay. Could we be wrong? If that, careful.
Oh, damn.
This is the goofy one. We could be wrong, correct? We could be wrong. The vaccine might be working, but we just said it wasn't. So that would be a false negative. We said nothing changed, but maybe it did and we missed it. That's a false negative, right? That's like going for a disease test and the test coming back clean, but you actually have the disease in your body. That's a false negative, right? That's a false negative. What's the chance of that? Trick question. You
Beta.
don't know. It's very nice answer. It's beta. We call that beta. We call type 1 error alpha, 5% alpha. Call it beta, but we don't know what it is numerically, Alina. Why don't we know what the value of beta is?
It's on a different curve.
If we're wrong about this decision, that means the vaccine is working. So here's the flu rate without the vaccine. That means the vaccine's actually down here. The flu rate's actually down here away. Where's that? That's the problem. We don't know where that is. And that's why at this point, I don't want to get into calculating beta. Because you have to know where that center is in order to calculate it. Does that make sense? Just realize right now what kind of error you could make. With a big p-value, if you want to make it concise, let's make it concise. If you want a big p-value, you can make a type 2 error. Right? If you get a big p-value, you can make a type 2 error. Because a big p-value means you're going to say nothing changed, which means it's a negative test result. You could be wrong. False, negative, that's type 2. With me so far? If you get a small p-value, you're going to say what? Small p-value, you're going to say
Something changed.
something changed. And you could be wrong. With a false positive. With what likelihood?
5%.
There's your 5%. And the reason we know that is because we're setting this curve up at 95% confidence, and we know where that center is, as Michael pointed out before. Fair enough? Good. I want to do one more finagling of this curve. I've never spent this much time on this particular one. So wait, I want to thank you for asking that question. I think this is helpful to keep looking at this curve and finagling data. Ashley asked a fantastic question 2 minutes ago. She said, is it possible? She saw this result right here. See how that bad boy's bigger than a half? That means that we actually fell to the right of average, which means we're actually above the 12%, aren't we? More than 12% of our sample got sick. But the question is it significantly more than 12%? Is it significant? Is that significantly more than 12%? To believe maybe, can I go over and finagle the hypotheses a little bit? Ashley's saying, dude, maybe we should say dude. But she's saying maybe your flu vaccine is actually getting people sicker. Sicker than they usually do without the flu vaccine. See that? Because all of a sudden the data fell to the right of 0. So maybe it's making people sicker. Which would mean that the alternative would be the opposite, obviously. So just, you don't have to change it in your notes if you don't. I have an example with some data to play with next time. We're running out of time here. But is this true now, based on that data? Do we believe that, based on that result right there? So we were trying to see that the flu vaccine actually is lowering flu rates. Is it raising it significantly?
Yes.
Oh, good. I see this. I see a couple of yeses and a couple of no's. Well, let me ask you a question. If I reran this test in your TI, what would the p-value be? You can answer this without running the test. You'll know what the p-value is. Well, they're always going to be less than 1. But what is it going to be exactly numerically? Say that again, Mary. Oh, it's off.
35?
It's going to be this. It's going to be that. Because if you change the sign of your tests, you've now set up your confidence interval to not start here and go that way infinitely. It's going to have a high point and go down infinitely. Does that make sense? You're setting up a one-sided confidence interval looking for an increase instead of a decrease. Just like we did with those elite male cyclists. We were trying to see if their heart rates went down, but then we checked the lung functions to see if they went down, and then we checked the breast cancer survival rates with green tea to see if they went up. There's all kinds of times you want to look at a confidence interval going the other way versus down. So this has to be exactly the complement. This is 65%. That would be 35%. So since it's big, i.e. 35%, does it look like the flu vaccine's making people sicker? Does it look
like that?
Because it's over here, right?
Yeah.
But is that small enough for us to believe? Remember, the only time we're going to think something's changed is if your p-value comes in under 5%. We'd have to see a lot more people sick than 124 out of 1,000 in order for us to push this out far enough. More on that next time. More on that next time, okay? More on that next time. I have 3 more data sets I want to play with in class. And then we'll start looking at average testing too. Cool. So next time, project and or quiz, if you choose to do the quiz.
Oh, I'm glad you